Alright, so this is welcome. This is our lab for the camshaft and crankshaft position sensors. And right here we have a lovely 2006 Suzuki Grand Vitara. And if we look at our lovely wiring diagram right here, we can see that these are our CMP and CKP sensors. They're 3 wires, which means that they're Hall effect sensors. And also looking at our picoscope, we can tell that these are, in fact, right, don't look at the blue one, it came out, but if we look down at our red one, we can tell that this is a Hall effect sensor because they're stuck at 5 volts, and Hall effects are pull down, not pull up.
Here we can see the sensors pinned out. So here is our CMP sensor, and our CKP sensor is in the back. So we are pinning out at the ECU, or PCM.
Hall effect sensors were discovered in 1879 by Edwin H. Hall. He discovered that voltage is produced if a magnetic field is exposed to a semiconductor, which is what this vehicle is using in both our CMPs and our CKPs, which are down there, but we have a back probed up through the PCM. And go ahead and start the vehicle. Our red wire, the red line is our CKP. This is our CMP, but it's not reading right. Give me it. There we go. And so if we pause it, you can look. Our CKP is what reads our RPM, and we are getting 527 hertz as our average, and 52 hertz for our CMP. You want to go ahead and rev it a little bit? As we can see, as the engine speeds up, our lines get closer and closer together. PM displayed. When the engine speeds up, our frequency increases on our CKP. So the CKP right now, it is hooked up to this, and how the computer tells how fast the engine is going to determine our RTMs are these little gaps right here. It has little notches in there, and whenever it spins around, it affects the magnetic field, giving us these little gaps, and there's one tooth missing. And we can see our RPMs. As you can see, slowed back down from our high frequency.
This is the camshaft and crankshaft position sensor lab on the 2006 Toyota Corolla. We have our crank sensor down here and our cam sensor up here. Currently they're both 2 wires, so they're variable reluctance, and we currently have the crankshaft sensor wired into an ohm meter, and we are getting 2000 and roughly 67 ohms, which is within the resistance reading at cold for the crankshaft position sensor. Here's the ohms reading of the camshaft position sensor. It is currently plugged straight into the sensor and is getting roughly 1084 ohms of resistance, which is within spec for a cold position sensor.
Perfect.
Here we have the camshaft and crankshaft position sensors hooked up to our pico scope. Real quick, here is our wiring diagram. As you can see, they are both 2 wires, which means they are, as stated before, variable reluctance sensors. And so they'll generate a AC voltage,
AC current.
yeah, AC current, and
Here they're variable relucting. All right.
yeah, they're variable relucting in this beautiful scope right here. And now we will increase our RPM and watch as the amplitude increases. Yup, see, look at that increase. Yup. Gorgeous increase. And then it settles back down, as with the RPM settling back down as well. This is the camshaft position sensor and crankshaft position sensor lab on the 2021 GMC Terrain. We currently have both the camshaft and crankshaft sensors hooked up to the pico scope. This is the location of the camshaft sensor, and the crankshaft sensor is located underneath the car on the back of the block right by the transmission, which has already been pinned up. Here's our wiring diagram. They are both 3 wires. And from the looks of the pico scope, when the car is on and the engine is off, from this we can determine that since we have 5 volts at our crankshaft, that our crankshaft is a pull down and therefore a Hall effect, while the camshaft, when the car is on with the key off, is down, so we pull up, which means it will be magneto resistive. When we start the car, you can see here it is being pulled up, and here is being pulled down. And we can see the missing teeth. Every so often it flashes up here. These ones are more obvious. Is with the increasing RPM, the space between the space of the missing teeth gets smaller and smaller as the RPM increases. And the space widens back out as the RPM falls.